Hey, hi YouTube, how are you? I hope you all guys are doing great. In this video onwards, we are going to create a new series on pandas, and basically we are going to launch 7 different videos on pandas. And on these 7 videos, I will try to cover everything from basic to advanced, and also to cover the real world use case and the best practices and tips and all things with complete theory as well as complete practical knowledge. So let's see what are the videos going to be. First one is the introduction to pandas. So today we are also going to cover in this video this introduction. Then we will have data reading, how we can read the data from different sources and how we can write the data. Then the third video will be on data cleaning and the transformations, which generally we do at the job. Okay, so it's really, really important. Then we will be seeing some advanced manipulations. So whatever manipulations we need, we are going to cover it in this video. Then in the fifth video, we are going to see the performance optimizations. So whatever performance optimization we need, we will explore here. Then we will see the real world use case. This is going to be really, really exciting, and we will also cover EDA because in EDA we heavily use pandas. Okay, so EDA is basically exploratory data analysis. Let's suppose you are having a very huge data and you want to explore patterns and you want to clean the data, you want to manipulate, you want to derive some features and all, you can do it. We will see in the future videos. And the seventh video will be tips and best practices. So whatever the best practices are, I am going to share you some knowledge around it. Okay, so this is all the structure of what we are going to cover in this Panda series. So if you are new to this channel, please subscribe so that you can be tuned with us, and whenever I bring some new videos, it will be helpful for you. Now let's see introduction to pandas. So this is the first video, and I can say the most basic videos on pandas, and we are going to have theory as well as practical. Now first let's see what actually pandas is. So pandas is basically an open, it's actually a Python library, and it's open source Python library. Okay, so this is the first thing. Why it's what actually mean by open source? Open source means you don't have to pay something to use it, and it's basically it's open. The source code is available, and anyone can go and contribute to it so that it can develop a lot. Then it is basically used for data manipulation and analysis. So it's generally used for data manipulation and analysis of the data, and it is built upon NumPy. Okay, so if you are not aware of NumPy, it's a library, again a Python library, which is used for numerical computation. By the name, it is clear. NumPy means numerical Python. Now let's see what are some features of pandas. Okay, so let's cover some features of pandas. So what features it provides, so that we should learn it and whatnot. So first feature, it's used to handle missing data. Okay, so it is used for handling missing data. So you might have a big Excel file and there are some data missing, or the data is not good and we have to clean the data. So we use this pandas to handle missing data and cleaning the data efficiently. The raw Python can also do it, but it's more efficient if we use this kind of libraries like pandas. And it also supports multiple file. Okay, so we have multiple file support like CSV, JSON, SQL, Excel, Parquet, whatnot. Okay, then it also allows powerful operations. We are going to see a lot of operations in throughout the series. Then its integration with libraries like NumPy, or we can say Matplotlib, or maybe like scikit-learn and many more, is quite seamless. So Integration with these libraries are good with when of pandas. So I already explained you about NumPy. Matplotlib is again a library used to plot graphs and all. And scikit-learn is basically a library built on Python. It's built over NumPy, SciPy, and Matplotlib actually. So in future I'm thinking of creating videos over all these topics. Let me know if you are interested. Then why should we use pandas? Okay, why to use pandas? So let's see why we need to use pandas. Is it really necessary? So it make easy to work with structured data. Okay, so whenever you have structured data, it makes the works very easy because it provides two different data structures or structures which is called as data frame and series, which makes the thing easier. And we already talked about the data cleaning jobs is much easier when we use pandas, and it's basically fast and efficient when we compare it with raw python, because all these things we can also do with raw python, but if we have a library which makes it much faster and efficient with less code, it's better. Okay, now let's see how we can install pandas. So you can use VS Code or whatever you want, but I am using Google Colab. If you don't know about Google Colab, it just provide a cloud notebook. Just you can go to Google and then search Google Colab, and you can open a notebook. So how you can install pandas? It's very simple. It's available in pip. So just go and write pip install pandas. Okay, let me give it a run, and it has been installed. Now, before moving to more practical, I would like to explain something about the series that I was talking about, series and sorry, the structures that I was talking about, which was series and data frame. And definitely we are going to also explore it a bit. We will be seeing the code. Okay, so first one is series and second one is data frame. So series is basically 1D labeled array. Okay, so when we will be doing some experiments and coding, I will explain you what I mean by labeled. Now, which kind of data it can hold? It can hold any type of data. Okay, any type of data it can contains. Now, we can also label it like 0, 1, 2, we can label it. Okay, but if labeling is not available, it will directly take the label as 012 as in Python. If you don't know about uh, indexing, let's suppose we have a list. Okay, let's suppose we have a list. So the indexing of first element of list is 1, then 0, sorry, first one is 0, then 1, then 2, then 3, then 4. Whatever we do in programming, same it is in Python. So if you are not providing the labels, then it will choose the default label as 0, 1, 2, 3, 4. I will explain it each and everything in the code, and it will be much more transparent to you. Then what is the data type? So the data type is basically of elements of this series, data type of element in the series. So if our series is containing integer value, the data type of series will be also integer. If we are having float, it will be also float, and so on. Okay, so the data type depends upon the elements of the series. Now let's see some practicals and you will understand it much better. Okay, because theory sometimes it's not that great. Okay, open settings, and what I want is adaptive theme, light theme. Let's make it light because in videos light looks better. Okay, so now let's suppose we have a data and we have data like 10, 20, 30. Okay, so we have a list. It's a 1D array. Okay. Now we want to create a series from it. So series is equals to, you can name anything. Okay. This is just a variable. Okay. Now we have to import the pandas. I forgot to import pandas. So import pandas as PD because we want to use this pandas as PD. If I will not write this line, then here I have to write pandas, but I don't want it every time, and everyone use like this only. So PD dot, I have to create a um, series from this data. Okay, so let's print how the series is looking like. Okay, let's print it. Okay, spelling is wrong at both the place, so let me make it right. Yeah, so this is how my series will look like. See, now I haven't provided the index. So it will choose 0 as index, 1 as index, and 2 as index, and the value is 10, 20, 30. But we can also provide labeled index. Okay, what I mean by labeled index, let me explain to you. Okay, so again I am adding the same data, but now I will also pass the index. It will auto complete it, just wait. Okay, so index. So index, I can provide some index like I don't want the first row as 0, instead I want it as 1. Okay, so and I'm passing some strings. Okay, 1, 2, 3. So now if I will print it, then the first 10 is having a label as 1, 20 is having a label as 2, 30 is having a label as 3. And what is the data type? It is integer, 64-bit, depending upon the, it depends upon the system. Okay, now why the data type is integer? Because I told you that the data type of series is dependent upon whatever elements we are having. Okay, now can we also create a series using a dictionary? Why not? Okay, so let's suppose we take a dictionary. Okay, I think you might be knowing what dictionary is. So this is our dictionary. This is how our dictionary looks like. So there is a variable a, so the key is a, the value is 10, key is b, value is 20, key is c, value is 30, and we want to create a series out of it. So all the keys will be considered as the label, and the actual value will be considered as the value. Okay, so this is one of the way how you can also create your series using your dictionary. Okay, and I have also taught you how you can parse the index. Now let's see some operations actually. Okay, now if I want to access this 20, so what is the label of the 20? It's b, so we have to pass the label of it. Okay, so let me write some comments here. Access elements, uh, elements of series, and let me add some comments so that it will be helpful for you when I will provide this code to you. Okay, create a series from list, and this will be a series from list with default index, which is 0, 1, and all. And let's suppose I want again create a series, but this time I don't want with default index, without default index. Okay, and this is how we are creating a series from dictionary. So it will be like create series from dictionary. Okay, so we can also create series from dictionary. Now let's try some operations like access elements from the series, and we want to access this 20. So how it will be? So print, and we will pass the series, and if we want to access 20, the labeled value is b. Okay, so we will pass not a, we will pass the b, because we want to access the value as the value of label b, which is 20. So this is how we access the value. Okay, now let's perform some vectorize operations. Like I will show just one, because 10, 20, 30 is a vector, and if we multiply something like this, or maybe if I let's multiply 2 with all the elements of the series, and if I will print it, so it will become 10 into 2, 20, and 40, 60, some such kind of things. Okay, so vectorized operations are also there, so that's why it's quite handy. Okay, now if I will do filtering. Okay, so let's do some filtering here. Let me add the comment here. Okay, filtering, and let's suppose I want to filter it, and I want all the elements which are greater than 15 or 20. So this is how actually you can do it. So this will create another data frame which will be of series, and it will include all the elements which are greater than 20. Maybe what we can do is we have 10, 20, 30. So okay, one more thing. Okay, so now you might be thinking that I have multiplied this series with 20 with 2, then the original data frame or the original series might have changed. So let's see whether the original series has been changed or not. Okay, so if I let's me print the original series, it's still 10, 20, 30. It was just an temporary operation, not a permanent operation. If you want to permanently multiply 2 and store, then you have to store this series in a variable. Okay, so it will be like series is equals to series multiply by 2, but currently we don't want it. Okay, so if I want to filter, like I have 10, 20, 30 values and I want all the values which are more than 15, so this kind of filterings also helps. So we got two values, 20 and 30, which are labeled as B and C. So these are some operations that you can perform on the series. Now I have a question for you, a quick question. So please pause this video, and once you get the answer, you can write in the comment section. So let's suppose we have a data frame, we have a series as mostly we generally use data frame. So it's whenever I heard pandas, it's completely like data frame. Okay. So 10 is integer, hello is a string, and some we have mixed the values. And now I am creating a series using this data. Now, if I will print this series, what will be the data type? So please pause this video and let me know your answer and why you are telling like that. So if I will print it, I got it the data type as object. Okay. Why? Because it always upcast to accommodate all the elements of the series. Now let's suppose I'm maybe I can erase some values and I want to just keep this 10 and 3.14 integer and float. Now the data type has been changed to float. So it always upcast to accommodate all the elements. So the let's suppose we are having integer and its size is, let's suppose, 2 bytes. Okay, and let's suppose we are having float. Let's suppose its size is 4 byte. So the whole size will be the whole uh, size of, or the data type of that series will be the bigger one, which is float, so that it can accommodate all the elements of that series. Okay, so this was a good question. I think it can sometimes user ask in the interviews and all. Now, I think this much is enough for the series. You can explore a lot of different operations. Just go and write series and dot, and it might pop up a lot of different functions like this. Okay, so you can explore it on your own, but these are the most used functions. Now we will explore data frame. Okay, so let me write a markdown here, and we will now explore data frame. Okay, so this was the part of series. So series is done here. Okay, so let me hide the series now. Okay, and now let's explore data frame. So one of them was series and another structure is actually data frame. Okay, so and data frame is mostly we use every time. Okay, mostly we use data frame only. You will heard this a lot, you will hear this a lot. Okay, if you haven't heard, then you are going to hear it a lot. Then basically what is data frame? Data frame is basically it is 2D labeled data structure, and it's analogous to tables in SQL. Okay, so if you note tables, it's similar to tables in SQL. We and pandas it called as data frame. So it has rows, columns, data, and shape. Okay, so this is how a table looks like. Okay, this is how a table looks like. So these are the rows, these are the columns, and each cell represents data. Okay, this is data and the shape. So how many rows are there? 3 rows. How many columns are there? 4 columns. So the shape is 3 cross 4. Okay. Now let's do some practical so that you will understand about the data frame. Okay. So let's create some data. Maybe like we can create something like this. We can create a dictionary. I think it was giving, no, yeah, this is a dictionary. Okay, so we are having key as name, and we have Alice, Bob, Charlie, and then we are also having age as key, and we are having their ages, respective ages, and city, their respective city. This is the data we are having, and we are trying to create a data frame. So how you can create a data frame? pd.dataframe. In series we were using pd.series, pd.dataframe, and we are passing the data, and let's see how the data frame will look like. So it is looking like this, which is basically a tabular structure. Okay, so this is our tabular structure, like and these are the indexing 0 1 2 because we are not passing the indexing, so it will consider it as 0 1 2. If you will pass the indexing as, let's suppose, you do, like let's suppose you are explaining to a non-technical person and he's saying why the first row is 0, it should start from 1, because they don't know this programming and all. So here also we can pass the indexing. Okay, and let's suppose the first index is 1, then second is 2, then we have 3. Now if I will run it, then you can get the first is the indexing or the label is 1 2 3. So Alice is having, this whole row is having one label, this whole row is having two label, this whole row is having three label. Okay, so this is how you can create a data frame, and generally in practice we don't take this kind of data. Instead it is in a CSV or Excel format. Just to explain you, I am taken like this. Okay, and mm, yeah, that's it, I think. Let's perform some operations. Okay, so let's perform some operations here. Okay, I want to perform some operations. Like the first operation is like access the columns. Okay, now let's suppose I want to access all the data of name column. So what I will do, like this, print df name data frame and then the column name, okay, inside a square bracket. Okay, and name is a string. So if I will do it, then what I will get, all the value of the name column, Alice, Bob, Charlie. Okay, what I can do is I can also access more than one columns. So how it will be like print df, and let's suppose I want two columns. Let's suppose column one is name, second column is, let's suppose, uh, maybe age. Okay, so if I will do it, I will get two columns. We can also access multiple columns like this. Okay, and how we can access the row. Okay, this is a bit interesting part. Okay, how we can access the rows. So to access the rows we have two things. First one is ilock and we have lock, and the difference between them, understanding the difference is really really important. So let me take you to the whiteboard first, and where I can explain you what is the difference between ilock and lock. Okay, so ilock is basically, we call it as integer location. Okay, integer location, and lock is basically labeled location. Okay, so I explained you that, let's suppose we are having row 1, we are having row 2, we are having row 3. Okay, and let's suppose the index is 1 2 3. This is labeled index, but we also know that in Python, the default index starts with 0, 1, 2, 3. So also for this whole row, there is one more indexing, which is considered this as 0, this as 1, this as 3. But the labeled index is 1 2 3. So whenever we will use this labeled index, we will use lock. But if you want to use integer location like this 0 1 2 3, then we will use ilock. Okay, let me explain you, you will understand it better when you will see the code. Okay, because no one can explain better than the code. Okay, so what data we have, so let's print the data frame and let's see what data we have. So we have this data frame. Okay, so there are three rows, three columns. Okay, three rows means actually name, age, city are the name of columns, so I'm not considering it. Okay, now we have three rows and three columns, and I want to access the first row. Now let's use ilock. And what is ilock? It is integer location, and it uses the indexing of Python. Okay, so the first one is 0, then 1, then 2. Okay, so now if I have to print, so what I will do, df.ilock 0. So it will print the first row, which is the Alice row. Okay, now let's print it. Okay, so I got Alice, its age and city. Okay, now if I want to use lock, okay, so lock is basically location based, sorry, labeled location. Okay, we call it as labeled location. Okay, so it uses the labels. okay, that user has already provided. So if I will print and if I do it like log and 1, it will also give me the same result of Alice only, but it is using this label. And why I'm not passing it as, sorry, why I'm not passing it as 1, you might be thinking, because I have provided labels here and it was itself is a string which is 1, 2, 3. It is a string which is inside quotes, it is string. Okay, so that's why I'm using labels here. So there are two ways. Either you can use integer location, either you can use labeled location. Okay, now if I want to just select this city which is New York, then how I can do it? Okay, so if you don't know about metrics, I need to teach you something. Let's suppose currently we have 3 rows and 3 columns, isn't it? So we were having 3 rows and 3 columns. Okay, 3 rows and 3 columns. So this is a row, this is row, and this is column. So the indexing in Python starts with, or any language, 0, 1, 2, not any language, most of the language. Okay, so it start with 0, 1, 2. Okay, the indexing of most of the languages start from 0, 1, 2, and for the column also 0, 1, 2. Now if I want to access this particular value, so it will be 0 comma 2, first row and then column. If I want to access this, 1 is the row and 1 is the column. If I want to access this, what is the row? 2, and what is the column? 2. Is it clear? Okay, this needs to be clear. Now let's suppose I want to access this New York. Then what I will pass? So what I will do is print. If I want to use iloc, then def iloc, and I will pass something like this. Okay, so first, sorry, if I want New York, then it will be 0. So first go to, sorry, I want iloc. Okay, so if I want to use iloc, then it will be df.iloc, and just go to 0th. I think this auto completion is screwed. Print df.iloc, and then I have to pass first 0. So if I will pass 0, we have already seen that this will give me access of this row. Okay, but I want New York, so just I showed you it will be 2. So 0 and 2. So if I want to show something like this, Alice, then we have 25, then we have New York. Okay, sorry, New York. Okay, so sorry, then we have New York. Then so this is basically 0th index, this is 1 index, and this is 2 index. Okay, and this Alice is itself as it is at 0 index. So first of all, when we will do like this iloc 0, so it will give me this row, this complete row, Alice, 25, and New York. Now inside this row we also have indexing 0, 1, 2, and this 0, 1, 2, if we want to just access the New York, so it is 2. That's why I have also explained you New York was at this position, isn't it? So that's why we have used 0 comma 2. I hope this is clear. Okay, if it is not clear, let me know in the comment section so that I can help you. But okay, let me take it to here so that it will be better, so that all the iloc will be at the same place. Now let's suppose I want the same functionality with lock. Okay, so now this lock give me three things again: Alice, 25, New York. But now I cannot access through 0, 1 to integer kind of thing. I have to pass something else. So this, out of this Alice, 25, and New York, I want the city. So I will just pass here the city. So it will again give me New York. If I will pass it here as name, it will give me Alice. So this is how it works, iloc and lock. Iloc is more towards integer location, like we use the indexing of Python, and lock is mostly labeled location. We use the labels, okay, and we doesn't use the indexing of Python. So this is the very basic difference between iloc and lock. I hope you have understood it, and if you haven't understood it, please let me know in the comment section so that I can provide you resources, or I can create another video on it. But if you will try it on your own, I'm sure you will understand after seeing this video. Now, let's suppose this is our data frame. Okay, this is how our data frame looks like. But let's suppose you got a huge data. Okay, leave the huge data. Let's focus on operation first, and then we can consider the huge data when we will learn about how we can read the data from CSV, and we have millions of rows and all. Okay, but what actually we do? Okay, so whenever we get a data frame or the data, let's suppose we got the data in CSV, then we convert that into a data frame. Okay, we will explore it in the next video. But let's suppose we got a data frame which is having huge data. Forget that we have just this much data. Okay, this is the actual thing to read the CSV file, but that's don't focus currently. Now, if we have to see the summary, okay, if I want to see the summary of that particular data frame, so what I will do, it's simple. df dot info. Okay, it will try to complete it. df dot info, and let's give it a run, and it will give us the info. Okay, it will give the summary. Okay, like name has three non-null column. Name has three non-null records, so there is no null value, everything is filled, and the data type of name is object. Age has three non-null values and the data type is integer. City has three non-null values and the data type is object. This is the memory usage. This is the data type. So we have one integer and two objects because string is considered as object. Okay, and it is of pandas data frame class. Okay, it's not like only panda support data frame. But Spark and all things are also there, which have their own data frame. Okay, either you can use pandas data frame or Spark and so on. Okay, so this was about how we can see the summary of data frame. But let's suppose you are not more towards this summary. Instead, you want a statistical summary. Okay, so what you can do is just go and write describe. Okay, so it will give us more statistical summary, like the count of age is 3. We have total 3 age. The mean is 30, standard mean, and 25%, 70, 50%, 75%, and the maximum value. All these things will be given here. Okay, so this is more of a statistical summary. Okay, so if you want just the summary, you can use df.info. If you are want to explore statistical summary, this is helpful. Actually, this all things are very helpful when we do EDA. Okay. Now, if I am going to print df.head, okay, so it will just show me the first. No, sorry, not the first. Um it will show me the it will start from the head, but what I want to say is, let's suppose I pass some value. Okay, and if you want to read about head also, you can read. So it return the first n rows. Okay, this function return the first n rows from the object based on the position. Let's suppose I write 1, so it will return me the first row, which is Alice 25 New York. If I will write it 2, it will return me first 2 rows, Alice and Bob. Okay, if I will not pass anything, it will return all rows. Okay, then let's suppose we also want to add a column, and so this is let's see how our data frame looks like. So print df. Okay, I know I am printing again and again data frame, but it helps. Okay, I just don't want to go up and check everything. Now let's suppose we want to add column. Okay, so this was about um, weaving first and rows. Okay, and same we also have tail. So if we do tail, then from last we can see uh, uh, n records from end. Okay, from bottom. Then if you want to add some columns, so use the same df, and let's suppose I want to include salary, and let's suppose I want 3 salaries as 5,000, 3,000, and 1,000, and just let me also print this df now, and let's run it. So now you can see one new column has been added for each of the name, and the salary has also been added. Now let's suppose I want to drop a column. Okay, let's suppose I don't want some column. Okay, and this is also, this all things are really really important when we do some real case scenarios, like if we want to do some ED and on. Okay, so df dot drop, and what columns we want to drop. Let's suppose I want to drop a column which is maybe you can say salary. Okay, okay, I want to drop this column. If I will do it, it will drop the column, but we also want to store this result in a data frame. Otherwise, that operation will be a temporary one. Okay, so that's why we also want to store it somewhere. That's why we are storing it in a new data frame, or you can say, let's call it as new data frame. And if I will print now data frame and print the new data frame, there will be a slight difference. Okay, so let me just print something like this. Okay, sorry, it should be a string, isn't it? Okay, so let's do it. So here you can see that the original df is as it is. Okay, because we have not stored this whole value as df, we have stored it in new df. And the new df which we have, whatever we have dropped, we have also stored it in a new df. So new df will look like this, with the the dropped, with which will not include that dropped column, but the old df will be having the dropped column also. Okay, and let's suppose we can do some filtering and sorting also. Let's do some filtering here, and we can play either with the old df or new df. So let's play with the new df only. Okay, and let's suppose I want to print something like df, and I want to create a data frame where uh, the df and age. So this is how you access a particular column: data frame name and then age. I want a data frame where the people should be more than 28 years, or maybe more than, yeah, let's suppose more than 28 years, and let's give it a print. So now you can see there are two records. First one is Bob and Charlie, who are age of 30 and 35, and their respective details. Okay, now you might be thinking why. Is it clear or not? I think it's clear. I think still I'm not having a feeling that you have understood these things. Or let's suppose if it seems a bit confusing for you, so what I can do is, uh, let's do it like this. So filtered underscore df, and in this filtered df, so from original df, what we are going to take, we are going to take only the age column whose value is more than 28. And now if I will print this filter df, it will be like this. But the original df will be as it is. Okay, if I print this original df till here, it will be as it is, because we are not changing in the original data frame. We are changing in, and we are creating a filter df, which is a new filter, which is a new data frame. If you are a bit confused in this part, actually this part, which is filter df and df, and then in array we are adding this df age is greater than 20, and this, how it is getting like this. Okay, so let me just clear it. If you will just take it this part only and just add it here and just give it a print. Okay, so what you will get is, it will analyze all the rows, and for first label it is false, for second label is it true, for third label is it true. Now when it will look at this df, it will go to that location. Okay, so in the first location it is false, so I have not to include it. If second is true, I have to include it. The third is true, I have to include it. And how, I'm not sure, but how it will do it. So it will do it like df lock, and then how we do the lock. So we add it. So in the, if you do it like this, if you have seen here, like somewhere here I have taught you the lock and all. lock and ilog. So lock df dot lock, and then we pass the label value. Okay. So what we are going to do is df dot log, and then we are going to, sorry, we are going to pass the label value, which is 1. Definitely we don't have to add 1, we have to just add 2. So it will choose the second one, and the second is for Bob. And similarly, we have also true for 3. So it will also select 3, but it will not select the first, which is Alice. That's why we are just getting 2 rows, and that's why we have to add like this. First of all, this will make, it will analyze the whole column for only the age column, or for the whole rows for age column, and it will mark true false, and it will also have that label index, which is 1 2 3 in this case. And then this df will use some lock operations and all, and internally it will try to extract the whole data for that particular row, which satisfies this condition, which is df age is greater than 28. I think now it is clear. Okay, so we have created a data frame, and we have only chosen the row whose age value is more than 28. And we can also sort these values, like let's suppose we want to create another data frame as sorted data frame, and we want to sort it. Df dot sort, sort values is the function actually. Okay, and we want to sort it by age. And let's suppose we want to ascending, we want, let's suppose we are making it as false. It means it will be, it is not in ascending order, it is in descending order. So the highest age will be at the top, so 35 30 25. And if I will make it as true, it will be in the ascending order. So 25 30 and 35 will be the thing. Okay, so this is the thing. Now, I think this much is enough with the operations for data frame. Also, we will be looking in future whatever we need more, but I think this much is enough. And now, what we can do is, let's see what are actually the uses of this pandas. Okay, so uses are like, uses includes a lot of things, like we can note it down somewhere. Okay, so uses are first, very important, which is tabular data analysis. But whenever we have tabular data, it's highly useful, highly recommended to use this tabular data analysis. Then we also have to pre-processing the data. So whenever pre-processing is needed, we use it. Or we can say aggregating, or we have to aggregate or summarize the data, we use it a lot. Okay, so these are the uses of pandas. And in next video we are going to see about how we can read the data. But before that, let me tell you how actually the workflow happens in, whenever you are working in this EDA or using the pandas and all, how actually workflow works. Okay, so first of all, whenever you will get the data, you have to load this data, okay, into pandas or something like that. Then you have to inspect the data, okay, like how many rows and columns are there, how many non-null values are there, what not. You have to summarize it. Then you have to clean the data. You can have some you can have some null values or something like that. You have some noise, you have to clean the data. Then you have to again analyze the data, because this analyze can be helpful for the business. And then you can export the data so that it can be input for your ML model. Okay, now what are the applications of it? So we have seen, like if you are having a messy data, you can clean it, you can analyze the trends, and this prepared data, this export data can be an input for your ML models. Okay, so that's it. In this video, we have seen a lot of things about pandas introduction, and we have also seen series and data frame. And in the next video, we are going to cover the how we can actually read the data and how we can write the data. Okay, so that's it. If you like this video, please give it a thumbs up, and if you have any doubt, please let me know in the comment section. I will be there for helping you. Thank you. Have a nice day.